All right, now that we have looked at how to run fibers manually, I want to start looking at Zio's combinators, or more specifically, their parallel combinators. And the first one we're going to look at is right here, and it's called collectAllPar. So I have an application here called collectAllPar examples, and what I'm going to do down here in the run value is I want to run a successful example shown here. I want to show a failure example where you know that one of these is going to fail. And then I want to run an uncertain example, which is this one down here, where the code doesn't necessarily know, oh, this one's going to fail. And then, oh, when that happens, how should I handle this? I think this is more of a real world example, but I want to start with the others first. So the first one is a successful example. So this is a variable named successful example, and it's a Zio effect. And when I keep the cursor there, you can see the type is a Zio of any, IO exception, and unit. So the first value here I'm calling a successful example. It's a Zio effect. You can see I run it in a for expression. And then I call collectAllPar right here. And you can see that collectAllPar takes some kind of list or iterable over here. So if I were to look at the code, you would see over here it's taking an iterable type. So list is an iterable type, seek, vector, etc. All those are iterable types. And then inside the list, we have three different effects. All three of these, I'm saying, are going to succeed. They can't possibly fail. And because of that, I get a result here, and then I'm going to print the result here. The second case is an effect that is going to fail. So the second effect here is going to fail. Everything else is the same. I have this variable name for this effect, a for expression. I use collectAllPar with a list. I have a succeed. Then I have a fail right here, and then another succeed. So we'll see how that works. And I have a note here to myself to look at either. So the first time we run this, we're not going to use either, and we'll see what happens there. And you may think about that already if you have some experience with collectAllPar, and think to yourself, given this code that Al is showing right here, what's going to happen if he doesn't put that either on there? And as I mentioned, I think the third example here is more of a real world example, because when you're running real world code, I think you rarely know if it's going to succeed or possibly fail. So what I do here is I have succeed, then I have an attempt, and you can see it's going to throw exceptions, so it's going to fail, and then another succeed. Here we add .exit on the end of that. And that .exit gives us a result over here. So I call this uncertain result, and you can see that type here is an exit, and it's going to have a throwable in the left position and then a list of string in the right position. So the throwable, of course, is going to be the potential failure value, and in the right position, the list of string would be the potential success value over there. So that's the way I'm handling that one right there. Then I print that, and then I handle the uncertain result right here with a match expression. And that has two possible cases. One is exit.success, which will contain that value, the success value. And then the other one is exit.failure, which will contain the cause. And bear in mind that value and cause are just variable names that I've given this code right here. But the important part is you have a match expression. And with an exit value, you can have an exit.success and you can have an exit.failure. So I just want to show the way you could possibly handle this here. And then over here, I do a little error handling with that cause value. So I call failure option and then get or else on that. Okay, so I think that's pretty much all we need to know. We'll see if anything else comes up here. So let's go ahead and try to run this. And we'll give that a shot. And you can see running example 1, all effects succeed. Running example 2, one effect fails. And then we get a nasty exception. And you can see here, second effect failed. We never even get to example 3. And what I wanted to show you is that's what happens if you don't put something like either or a .exit over here. So that blows up your code, which is, of course, a bad thing. It ran the first example, and then we got an exception on the second example right here, and then it never even got to the third one. So I just wanted to show you that if you don't do that, that's what's going to happen. And in this particular case here, what I had planned on doing was handling that with an either. So now we can give ourselves a little more room and run that again. And now you can see again that the first example succeeded. The successful result was a list of first, second, and third. So that's what we have right there. The second example fails as planned over here. It failed right there. And what I wanted to show you in this case is that you don't get the success values over here. What you get is just the failure. And because I called dot either over here, we get a left. And then it said the second effect failed. And that comes from this text right here. So again, in this example, that's what I wanted to show you is if something fails, you might want to handle it with dot either. Or if you're uncertain about it, then we come down to the third example. Let me get rid of that. The third example, we have succeed, attempt, and of course this fails with an exception right there. So then we have the failure message here, and that comes out of this code right here. So what happens over here is the first value succeeds, we attempt to do the second one, it throws an exception. And then what happens over here is we have collectAllPar going from there to there, and then I call .exit on the result of that. So this is throwing an exception within attempt, and then with collectAllPar, I'm saying call .exit on that, and that's what gives me this exit value over here on the left. And since this is an exit value, then I handle that down here with a match expression as I described before. So the error message we're seeing with the failure colon is this one right down here, the failure colon. And then the rest of the message is Java Lang exception second effect failed, which is the message that we put right here. So again, this is a first look at the collectAllPar function. And I wanted to show you these three different examples. So again, this one was intended for all to succeed. This one I knew it was going to fail, so I added either on that. This one right here represented an uncertain outcome. And again, I think this is a bit more of a real world one, because you can imagine calling web services, or you can imagine calling a database, anything that can possibly fail. And you will want to handle it something like this with the exit value, and then a match expression somewhere in your code to work with that exit value. So this for expression could have yielded this uncertain result as an exit value, and then I could have handled that inside of run. But somewhere in your code, you're going to want to have some sort of match expression like this to handle that result. So again, that's a first look at the collectAllPar function. And collectAllPar is known as a higher order function. It's also known as a combinator. And a combinator is a higher order function that combines one or more effects or other values to create a new effect. And this lets you compose and manipulate effects in different ways. In this specific case, it's also known as something as a parallel combinator. And this type of combinator is specifically designed to run effects concurrently or in parallel. And in Zio, they all have this .par at the end of the function name to let you know that it is a parallel combinator. And I accidentally put my notes about collectAllPar in another file, but I just found those here. So collectAllPar, used for parallel execution of multiple effects. The purpose of collectAllPar is to run a collection of Zio effects in parallel and collect their results into a single collection. collectAllPar takes an iterable of Zio effects as input. It executes all of those effects concurrently, and then it collects the results of all the effects into a single collection of the same type as the input. So what does that mean? If we look at the return type, you see that the return type is an effect that will produce a collection of results. So for example, if you pass in something like this here, this list of a Zio REA, what you get back is a Zio RE, and then the list of A will be in that third position right there. And of course, that assumes success. And then I showed error handling. So if any of the effects fail, collectAllPar will fail with the first error encountered. And then the documentation I found on this says that the execution of the other effects continues unless short-circuiting behavior is defined by the Zio runtime. So in regard to this statement right here, I don't think I proved that over here. I'd have to do a little bit more work over here, a little bit more debugging work. So I'm going to leave that as an exercise for the reader. And you can come over here and modify the second example or modify the third example to prove to yourself what happens in these examples. And what I mean by that is this first effect run here? Can you prove that that first effect is run or not? And can you prove that this third effect is run over here or not? And that's kind of trivial in a small example like this, but in the real world, that may be important. So that's why I'm stressing this statement right here, is that you may want to know more details about that. So go ahead and work with that with this example. Getting back to the discussion with collectAllPar performance, The function is ideal when you have multiple independent operations that can run concurrently. And in most situations, that will improve the overall execution time compared to sequential execution. So if you look at this code over here, if each one of these effects took 5 seconds here, here, and here, that would take 15 seconds if these were run sequentially. But when they're run in parallel, it should only take 5 seconds overall. So that's a real nice savings that you'll see when you run things in parallel. One thing I may not have stressed enough is that you use collectAllPar when you want to get the results from these. So you want to get them in the end as something like this, as a list. And the reason I'm stressing that right now is that in future videos, we'll look at other parallel combinators that are meant for different things. But collectAllPar is meant for this type of use case where you want to run 3 effects in parallel and collect their results so you can use those results, such as for printing that output that I have like here. So that one was performance, and then the last one is resource management. I've shown a little bit of resource management in other videos, but key here is that Zio ensures proper resource management, including automatic cleanup, even when effects run in parallel. So in previous videos, I think I showed the on-exit finalizer, on exit like that. And there are others. There's another one called ensuring. I can't remember if I showed this one. There's another one called finalize. When you're working with fibers, there's another one called on interrupt. And there are also some others known as acquire release, and a similar name with that one is acquire release with. So these are the names of some finalizers that can be used. And off the top of my head, I can't remember what I showed before. I think I showed on exit, but it may have been ensuring or finalized. But we'll talk about these more as we go through this course and future courses. I had a note here to discuss collectAllPar N, but I forgot it is not part of the Zio 2 API anymore, so please disregard this note. So again, that is a first look at the collectAllPar function.